Hello, I am the Macrobian Mr. Daycock, and today I'm going to be teaching you about using a particular case of the reverse chain rule for integration. Okay, so first of all, we're going to have a go at some derivatives. We're going to find dy by dx when y is each of these three different functions. I'm going to go through these quite quickly because they're there to demonstrate a point rather than being the key part of the lesson. So I would recommend pausing the video and having a go at these yourself first so that you get the full sense of what's going on. Okay, off we go. So we have y equals x cubed plus 2x to the 7. Now we're going to want to do the chain rule here with that as our u, and so we're going to get dy by dx is going to be equal to the derivative of the u, which is 3x squared plus 2, all multiplied by the derivative of the whole thing, which is 7 lots of x cubed plus 2x all to the power of 6. And then we can just simplify that a little bit and we get our answer to this as 7 3x squared plus 2 multiplied by x cubed plus 2x to the 6. Okay, next one. Here we've got y equals sine to the power of 11, so I can rewrite this as sine of x all to the power of 11. And again, our u here is going to be the sine x. And so we're going to get dy by dx is the derivative of u, which is the cosine of x, multiplied by the derivative of the whole thing, which is 11 sine of x to the power of 10. And then again we can simplify it and we get 11 cosine x sine to the power of 10, and that's going to be a bracket, 10x. Power of 10. There we go. Okay, now last one. First of all, we're going to want to write this with a negative power. So this is going to be y equals cosine of x plus 6x all to the power of negative 5. And our u is going to be the bit in the middle again. And so we're going to get dy by dx is the derivative of the u, which is negative sine x plus 6, all multiplied by the derivative of the outside, which is negative 5 lots of cosine x plus 6x all to the power of negative 6. And then we can simplify that, and we're going to get negative 5 multiplied by minus sine x plus 6 all over cosine of, got those brackets in the wrong place there, all over cosine x plus 6x all to the power of 6, positive 6, because it's now in the denominator. Okay. Right, now what is the point I'm demonstrating here? The point I'm demonstrating is the way that these look. In each and every case, if this here is our function f of x, then this here is the exact derivative of it. And this happens each and every time. If our f of x is sine x, then we still have our f dash of x here, we equal to cosine x, the derivative of it. And in each case we have the derivative multiplied by a power of the original function. And again here, this whole thing here is our f dash of x to our f of x here. And so what we get is this rule. If we have y equals to f of x to the power of n, then dy by dx turns out to be f dash of x multiplied by n f of x all to the power of n minus 1. And that's actually just a chain rule. It shouldn't be too surprising. But what it allows us to do is reverse it. But looking at it in this sense, we can reverse it and we can say that if we have an integral of something there where it's a derivative of function multiplied by f of x to some power, then what we're left with, and obviously dx on the end, what we're left with is we can integrate it and the f dash of x will sort of go back in, as it were, and this is going to be equal to f of x to the power of n plus 1 all divided by n plus 1, because we can just reverse that sense of our integration. And this here is a key rule. If you can see the derivative of one function compared to another, or where the other function is the power, notice this, we've got a derivative of a function and here we've got a function in a power, then we can use the reverse chain rule. So let's do some integrals with this as an example. So here our function is going to be f of x. It's going to be the 2x to the 4 minus x, and as we can see, this here is indeed f dash of x. It is the exact derivative of that bit inside. Hence the integral here is going to be 2x to the 4 minus x all to the power of 8 divided by 8. And that there is our derivative, our integral even, let's be precise, which is equal to perhaps 1/8. You could write it like this, 2x to the 4 minus x all to the power of 8. Now this one here, first of all, we're going to want to rewrite it as the integral of 5 over 2 sine of 4x multiplied by cosine to the negative 5 of 4x dx. And so our cosine's got a negative power, and now we've got exactly the same thing. We've got our cosine here, which is our f of x, and we have our sine, which is almost the derivative, and in fact our f dash of x is equal to minus sine of x. Okay, and so from there, this allows us to use our reverse chain rule. We know it's going to be cosine, and we have to add 1 to the power, so cosine to the negative 4 of 4x, and that 4x is fine, because notice there's a 4x in both. If there was only a 4x in one, then we would have a problem. We'd have to undo it, but because 4x is in both, we're good. And then we need to divide by the new power, which is negative 4. But there are a couple of other things to remember. First of all, we need to remember there is this 5 over 2 in front. And we need to remember this here was also in there, and so we need to divide by another 4. So we get another 4 on the denominator from that. And in fact, we need to remember this on both the last one and this one, and hopefully a couple of you were screaming at me on this regard, we have to put plus c on. And so we're going to end up with 5 over 4 times 4 is 16 times 2 is 32, so negative 5 over 32. And cosine to the negative 4, we can put that on the denominator, cosine to the power of 4 of 4x plus c. And maybe put the plus c in front for that negative. Ooh, almost. Let's be careful here, because remember, we recognise that this here had a negative as well. And so we need to remember to have our negative, an extra negative on here from this negative sign. So we've got an extra negative from that, the cosine differentiating to negative sign. And we've got an extra negative from dividing by our power of negative 4. And so in fact our negatives cancel out and we're left with 5 over 32 cosine to the power of 4 of 4x plus c. And at this point, if you're unsure of that, if you're like, ooh, I need to check that. This is the perfect time to go 5 over 32 multiplied by cosine of 4x, all to the power of 4. What does it differentiate to? Okay, and lastly here, the integral of sec squared x over tan x. Now, we have exactly the same situation here. You can write this as the integral of sec squared x tan x to the minus 1 dx, and the derivative of tan is indeed sec squared, so this here, this is our f of x, this is our f dash of x, but we have a problem because it's to the power of negative 1, and what we need to remember is powers of negative 1 don't integrate using our power rule, they have to integrate to a natural log. So in this case, actually, what we'll get is the natural log of tan of x plus c. And that is always the case. In fact, we can write another rule that if we're dealing with the integral of f dash of x over f of x dx, then that is equal to the natural log of f of x immediately. Okay. Thank you very much for watching, and I'll see you in the next video.